Hello everyone. This video is brought to you by the Atılım University OpenCourseWare project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and the video lectures are prepared by Ümit Alkuş. In this video, we will solve one problem in Chapter 10. The angular position of a point on the rim of a rotating disk is given by this formula, where theta is in radians and t is in seconds. A. What is the average angular speed for the time interval that begins at t equals 0 and t equals 5 seconds? B. What is the angular speed at t equals 5 seconds? C. What is the average angular acceleration for the time interval that begins at t equals 0 and t equals 5 seconds? D. What is the angular acceleration at t equals 5 seconds? E. When does the disk momentarily stop? First, using the angular position formula, theta of t, which is in radians, since angular speed is the first time derivative of the angular position, that is, omega t equals d theta over dt, we find 3 times t squared minus 30 times t plus 63 radians per second. Also, since the angular acceleration alpha t is the first time derivative of angular speed, therefore we get 6t minus 30 radians per second squared. In part A, to find the average angular speed for the time interval that begins at t equals 0 and t equals 5 seconds, we first find the angular positions at these times. That is, theta at t equals 0 is equal to 0 cubed minus 15 times 0 squared plus 63 times 0 plus 9. And the result is 9 radians. And the angular position at t equals 5 seconds is theta of 5 equals 5 seconds cubed minus 15 times 5 seconds squared plus 63 times 5 seconds plus 9. And the result is 74 radians. Finally, using the formula for the average angular speed for this time interval, that is, omega average equals theta of 5 minus theta of 0 divided by 5 seconds minus 0. And substitute the values into this equation, that is 74 radians minus 9 radians over 5 seconds minus 0, and we find the average angular speed for this time interval as 13 radians per second. In part B, we find the angular speed using this formula at time t equals 5 seconds. That is, omega of 5 equals 3 times 5 seconds squared minus 30 times 5 seconds plus 63. Therefore, we obtain negative 12 radians per second. In part C, to find the average angular acceleration for the time interval that begins at time t equals 0 and t equals 5 seconds, we use the same procedure that we have applied in part A. That is, omega at time t equals 0 is calculated to be 3 times 0 squared minus 30 times 0 plus 63. Then we obtain 63 radians per second. And we have already found omega of 5 as minus 12 radians per second. Therefore, using the formula of average angular acceleration, which is alpha average equals omega of 5 minus omega of 0 divided by 5 seconds minus 0. And put v of 5 and v of 0 into this equation as minus 12 radians per second minus 63 radians per second over 5 seconds minus 0. Therefore, the result is negative 15 radians per second squared. In part D, to find the angular acceleration, we use this formula. That is, alpha of 5 equals 6 times 5 seconds minus 30, which results in 0 angular acceleration at time 5 seconds. Finally, in part E, we use the angular speed formula, which is 3 times t squared minus 30 times t plus 63 radians per second. Since the disk momentarily stops in this part, then omega of t is 0. Therefore, rearranging this formula for t, we obtain 3 times t minus 3 times t minus 7 equals 0. From this equality, we obtain t1 equals 3 seconds and t2 equals 7 seconds. Okay, that's all for this problem. Thank you for your attention and see you in the next video.